This stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome to this digital signal processing, C++, JUCE, HISC and plenty of other things study group, and welcome to season 2024. Hello Fotis.
Hello Leandro.
So nice to be
Great
back.
to start the new year. Yeah.
And you have seen the struggles of advent of code. You know what David and I have been through. Wow, it was crazy.
It was a massacre of code.
Yeah, wow, day 24.
Numbers were crunched.
I still think of hailstones and rocks and coordinates in a three-dimensional space. It's, oof. But we are not here to talk about that. We are here to talk about digital signal processing and C++ and JUCE and music stuff.
Yes, but hopefully you will be able to apply your newfound knowledge into these topics.
You know, day 24 had the problem of a non-linear system of equations. And guess what? Non-linear systems of equations show up when you're doing physical modeling of analog gear. So it, again, was like a wall that I hit, and I'm like, okay, I have to put my head down and actually learn how to solve nonlinear equations, which will come in handy for digital signal processing as well. And it's about time. So that's something that I want to do in 2024. I want to be able to solve nonlinear equations.
And we may need those later on. Hint, hint.
Ooh, yeah, right. And in that case, in Advent of Code, the solution was relatively straightforward because there was a trick you could use to linearize the equations. But in the case of analog gear, there are in most cases, there are no tricks. You really do have to solve the nonlinear equation. But anyway, so how was your December?
Well, it was a bit slow. I was doing some film scores and stuff. I didn't do much with digital signal processing per se, but I did study a little bit more about modular synthesis. And I have a little thing to show you today, but before I do, so this is, do you see my screen?
Yeah, we do.
Yes. So this is the default synth in HISE, the template, but I painted it red. It was going to be green, but we'll see that in a bit. First, I wanted to make a little bit of a tangent because I wanted to discuss something very important when it comes to plugin UIs and UX. So Cardinal has been back in development, and I'm super happy about that. And one of those updated modules is the Surge brand of modules, and I love. So yeah, you basically have all the oscillators and filters from Surge XT in modular form.
Wow.
Now here is the very impressive part. So you may be familiar with mutable instruments, who are the most popular modules in the world. This is the recreation in Cardinal is called audible instruments. But anyway, this thing called texture synthesizer is based on mutable instruments clouds. So this thing, like all the other audible instruments, is designed to closely mimic the design of the original hardware. Now, the Surge guys, or Surge people, went one step further. So they created their own clone of clouds called the Nimbus. Now, sound-wise, they are pretty much the same, but there is a significant difference in the GUI. Like all the others, you can see that Surge has a similar interface for all, a uniform interface, which is great because once you learn one, you can learn all of them. Now, the annoying thing about the original and most clones of this one is that this knob is a multifunction knob. So you have to click this button in order to change this from reverb, dry wet,
which makes sense when you have
stereo
two hands.
spread. Yeah, exactly. Yeah, and feedback amount. The Surge guys actually laid out all four knobs in front of you, and not just that. You have, if you right click, you have those hidden modes, which I guess in the original are behind them. I don't know how you can do this, or maybe with those buttons, I don't know. And also you can change the quality. The Surge guys have them on a drop-down menu without having to right click, and you can see the setting that you have without having to right click and see which one is ticked. And last but not least, the feature that is in all Surge modules is also available here, because here you can modulate most but not all of the parameters. But with this multiple mod system, you can just modulate everything you want, and then just hook up an LFO. That's not an LFO, but you get what I mean. And you can modulate pretty much anything and everything we want. So it's those little things. Oh, and did I mention they have presets? But yeah, it's those little things that make this an interface more intuitive. And one could argue that because it's a smaller module and the knobs are closer to each other, that it should have been harder to use as opposed to this one, which is bigger and more laid out. But the fact that it's so clean, so well organized, so beautiful, the the knobs, the letters, everything is so well made that even the creator of the original hardware couldn't do it this good. So thank you, Evil Dragon, and the rest of the search team, and Bacon Paul, for making a module emulation that's better than the original hardware and every other emulation that's come before. Anyway, so about me, today I made this because I wanted to get back in HISC land. I didn't design this, I'm not that good yet. This is the basic synth template that you can get from GitHub. All I did was load the PNG files for the knobs and change the color in Photoshop from green to red because I wanted to differentiate it. And I did something else. This is a great, I need to change this color as well. I did something else. So the basic synth is emitting 4 kinds of waves, so sine and etc. This, for the time being, has only one, but, can you hear it? I have to change the settings in Reaper because, boom, boom. Right, it should be working now. So maybe I have to, oops. There we go. Sorry about that, it's a bit loud. And yes, I still have that problem. I still have that problem with the hanging notes, but that's not HISC's problem. It's probably my computer's fault. But,
what about your computer?
Yeah, I don't know. Maybe I have to restart. Maybe it's a problem with Visual Studio. I don't know. But it only happens with HISC and some UVI synths. Anyway, so let's turn off the filter and the envelope. And whoa, that turned off completely. Maybe I do have to have a sustain. Okay, I'm still learning how to use. Yeah, I forgot to turn up the sustain. There we go. So we can turn off the filter now. And the effects, because I want you to hear what's actually happening under the hood. So this is a regular saw wave, right? No, it's not. That's the gist. This is not an oscillator. It's a sampler that plays samples recorded from an oscillator. You may remember I have talked about this in a previous meeting. Last year, Sample Science created a pack called Analog Waveforms. You can get it from his Gumroad page for absolutely free, and or you can donate. And it's in the public domain, so just like Steamboat Willie. So you can pretty much use this in any synth you want without having to pay royalties to Sample Science. The difference is that he recorded 4 different waves, and this is my edit. This is the original. So let's say that this is the pulse width, the one that you're hearing right now. Do you see that the spectrogram is wonky? It's because these are generated from an actual analog synth, the Dave Smith Instruments Morpho. And the reason why I chose these particular waveforms, apart from the fact that they sound pretty good and loud, as you have attested, is that Pierre from Sample Science has embedded those metadata inside the WAV files. You can see in Reaper, these are the cues. And I have a macro here. As you can see, my macro toolbar is getting longer and longer every month. yeah, I'm gonna need this one. I'm gonna need a third row soon, and I won't be able to see my tracks. But yeah, if you click this one, oh, are you adjusting the light?
I'm adjusting the light.
Okay, so if you click this one, split at media cues, you have split up this waveform at exactly those breakpoints that sample science did. And the reason why he did that this way, because they are perfectly loopable. I'm gonna turn it down again. And let's loop it. Yeah, you heard a slight click. That's not the waveform's fault. That's my latency's fault. But apart from that, the waveforms are perfectly loopable. So I chopped those off. I only chopped those parts. I named them. And the amazing thing about HISC is that it can read the file names and it will automatically map the samples to the individual notes. I had to name them this way. And it can read more data if you embed them in the file. Now, the one thing I failed to do, and I have to probably bug David Healy about that, is that I have created two sample maps, one so far, one for the pulse width and one for the saw. It's a crossover between saw and triangle, SA3. This is the saw and the triangle. Eventually, it will have 4 of those. And I failed at creating a drop-down menu that allows you to switch between sample maps. David Healy has created one, and I tried to borrow it, tried to steal the code, and it didn't work. So I'm gonna bug him about that. And the other thing, 2 other things I want to do is, apart from the sampler, one of the options will be to have a sine wave, because sample science did not include a sine wave. And so I'm going to use the default HISC sine wave, because it's going to be generated, synthesized. But I am going to include a custom effect chain like the one I used in my synthesizer Wild, which is, if you remember, it was a custom effects chain with distortion and stuff that gave Wild its character. So I'm gonna do that to analogize the sine wave and to make it sound like the sampled waveforms. And maybe if I figure it out, Christoph Hart himself created this template, and you have the convolution reverb. But I am not going to use it for reverb. I'm going to use one of those IRs that use filtering instead of reverb. Because, convolution isn't just for simulation of rooms. You can actually simulate hardware just as acoustic audio, like 1 million IRs in one.
So, can you hear a difference between a waveform generated with an algorithm and a waveform that is in one of these recordings? Like if you play the 2 sawtooth waves, can you hear a difference? Like one sounds more digital and the other more analog?
The difference is extremely subtle. But the thing is that because those waveforms are wonkier than the algorithmically generated ones, I believe they're going to lend themselves to effects better. For example, the drive. That was too loud again. Sorry, I'm going to get you all deaf. So yeah, the drive amount, if I had applied it to a regular waveform, it wouldn't have generated as many harmonics as it would. I really need to fix that.
That's a lot of harmonics right there.
Yeah. And What else do I plan to do? And I also plan to create a different GUI. And I want to put them all in one page instead of having these tabs. I'm gonna cram them all and give 2 additional octaves, maybe 4.
It is true that these sliders take a lot of screen space, and if you collapse them into knobs, then you can have like maybe even 3 rows of knobs.
And that's about it for this thing. And now I have a little JSFX question that's very obscure. I don't know if we're gonna make it today. It's gonna be very hard, but we could at least create the building blocks today. So did I keep the... There it is. So I don't know if you shared, but there is a backend that allows you to run Faust instruments inside the JSFX. This one. First, sorry, I have to create this thing. I thought I had to add Faust to path. So I'll have to load it from the old-fashioned way. So there is our little Faust CD. Now let's go to the folder where I have copy-pasted this code into a file called JSFX. No, it's called osc.dsp. But let's call up faust.exe. Okay, so now we have to specify something. We have to load this, and I'm gonna replace the paths.
Also, I think that you have 2 Fausts in the command line.
Oh yeah, right. Let's get rid of that. And oh, it worked already? Huh. That's nice. And let's see the code. That looks like JSFX to me. Let's put it in the repair folder under mine. And yes, this time I am going to turn down the master volume. You never know. Oh, there it is. Wow. I was right, I had to turn down the master volume. But we have an oscillator in HISC. Oh no, sorry, in JSFX. And it's using Faust. So there's that. Does it correspond? No, because we have to do additional stuff.
Can we look at the code? I mean, can you stop that and then look at the code? I want to see what it looks like.
Yes.
Great. So they have a bunch of description lines. They have the sliders, pretty standard stuff, and the pins. That's very standard as well. And then they don't import any libraries, so all the code will be here. They do some memory allocation. We worked with memory allocation many times.
Wait, does that mean that it's loading the default Faust library? Because there is the standard Faust library in the original file. So did it take data from the original and embedded it in JSFX? There's one way to find out.
I'm pretty sure that there is, either in that library or somewhere else in the compiler chain, there is something that does, this is a binary, there is something that does like the bulk of the code, that does like in this case, os.osc, like the oscillator thing. Somewhere in there is a library that does that. And I bet that we are going to see the translation from whatever is written in Faust into JSFX, into that file further down.
Okay. Let's see.
So this init memory, alloc memory, zeros, all of that is probably not something that is in Faust. It's part of the glue so that we are able to interpret code in JSFX. And it's not even that interesting. For instance, the int32 function is just checking if x fits into an int32 representation. And by default, numbers are going to be 64-bit floating point numbers in JSFX. We don't even have any other kind of number in JSFX. But you can always check, would it have fit in that range of an int32 without overflowing? So that's just glue code. So let's continue scrolling. And all of that is still just glue code. It's doing operation on numbers using 32-bit numbers, and multiplication on numbers using 32-bit numbers. And we can even sort of recognize some stuff like the line that reads X and. That's a bit mask. And it's something that we have seen before. I don't remember the context, but I'm sure that at least Arya and I did some streams in which we needed bit masks. So it's just using a bit mask to mask so that you get the 32 bits at the end. That's the FFFF. That's a bunch of ones at the end, but discards the rest. So it's converting X into a 32-bit integer. Now, let's continue. MIDI scale is
even wrote
not even used here.
Some comments.
So it may just be that anytime you compile to JSFX, you're going to get the same preamble. It doesn't try to only search the things that will be necessary. Yeah, MIDI constants, it's not doing any MIDI, this thing. So let's continue. And then there is some memory layout, because what we are going to do is use JSFX to sort of emulate a runtime for Faust. And then you can translate the algorithms. So create instance may be of interest because it has to do with different voices. And we are using oscillators. And then it's initializing these instances. And in creating instances, it's just allocating memory. But in init instances, it may be doing something else. Isn't that funny? The L in L3 looks like a 1, so it kind of reads like 13, but it's actually L3.
13, yeah. That's a problem with, I don't know if you've heard of a new codec that's called AV1. But some fonts make the one look like an I, so it's gonna look like the AVI codec. But yeah, AVI is a container, not a codec, but you get what I mean.
Yeah, it's all in the same space of video. All right, so I'm not sure what's happening here. Doesn't tell me much. But whatever it is, it must be related to the oscillator now. And I wonder if all these additions in 32-bit integers is really necessary. I think you could be using the floating points. It's kind of odd that they do that. And then we finally have a line that rings a bell. There is a line that is like sine of, and then a long number, not huge. It's quite small, in fact, but it's a number, and then multiplied by something. So that may be the oscillator.
I cannot scroll horizontally. So there you go.
Yeah, and this object that they're referring to may be the phase. Though you would add the phase, not multiply. But anyway.
Then we have sample rate, create instances, initialize instances. Then we have this thing. Oh, this is creating the voices.
It's just, it's not even creating, it's looping over the voices. And
yeah, because what I saw in the manual that you have to do a different code just to have polyphony. Like you have to do this N voices for. Oh, and they are called N voices here.
Yeah, in this case you probably have only one voice, but it's still looping over all of them, which in this case is only one.
And we have another slider, the control one. Where is it?
No, the slider block of JSFX is calling this control function. And maybe they separated this into an auxiliary function so that it can be called in other locations. And we have seen that being the case when we were doing a graphical user interface, which this plugin doesn't have, but a graphical user interface, a custom graphical user interface, sometimes needs to update sliders, and it's not going to run the slider block of JSFX. So that may be the reason. But anyway, so there is a loop on the sample block. There is a loop over all the voices, and it is using all the auxiliary functions that we saw above. And there's a lot of like boilerplatey stuff that you can tell is boilerplatey because it has to compile from a different language, and you want to account for different ways of doing things. But yeah, it's not that much code. It is obviously code that was not written by a human, or at least it's obvious to me. Because I, as a human, don't tend to write this kind of code. But it's not terribly long or terribly difficult.
Yeah, in any case, I believe it's just a machine translation from one language to another. So all these functions in one way or another exist in Faust. So what the person who ported it was simply mix and match, I guess.
Yeah, there has been some work to write this glue, but it's not that
and
crazy.
You have even a comment. But yeah, we live in an era where even machines can write comments. Yeah. I'm looking at you, ChatGPT. Now I have one more question before we move on. And this is not directly related to this thing, but I want to make this little thing work. Maybe you have the answer. And I think that this is a Linux bash script. So I installed the Windows Subsystem for Linux, and maybe we can use it. I did install Cygwin, but I didn't figure out how to make this, how to run this. But still, if we have to use the Windows Subsystem for Linux, do I have to load this thing, or can I do it just from the command line?
I never used the Windows Subsystem for Linux, so I don't know the answer to that. I have never even used Cygwin for that matter. I always, if I have to do something on Windows, I do it natively. So if I have to install a library, I install the Windows version of the library or the Windows version of the tool. But let's see what happens. You have a shell.
Yes. So I'm basically gonna use Linux commands from now on in this place. And I forget.
Let's get our bearings. Let's see where we are. We are at home, it says on the prompt. There is a tilde there.
I have forgotten everything about Linux.
But let's see where home is. Can you pwg? That's a command, pwg. D as in data. So that's your home directory. And
yes.
Now we have to find a way of getting to the right folder. I wonder where the right folder would be. Can you ls on the command line so we can see where we are. There is nothing in our home folder.
Or .ls. Okay. I have forgotten all of the commands. How do you, like in Windows there is the CD. In Linux,
CD.
how is it?
It's
Let
CD.
me check it out. It's CD, okay. But is it gonna take it?
I don't think so, because the path is a Windows path. And even then you should put that in double quotes. As you see, now the prompt is looking different. That's because the backslash has special meaning. So put the whole, you see how the backslash turned the whole command into a single line? When you pressed up, a single line showed up. Yeah, so try to do CD and then double quotes and then the path and then double quotes, but I am highly confident that that will not work. Yeah.
Oh.
So now we have to see, first of all, if we can access the files from your Windows machine into the Windows Subsystem for Linux. And if we can, how we get there. It may be the case that it mounted your Windows volume as, and when I say we are Windows volume, I mean your disk, into the Windows Subsystem for Linux in a special well-known location. If it is following the Linux convention, it would be under /mnt. Can we cd space /mnt and ls in there?
Oh. See, oh, there's my drives, all my drives, C, D, T, and
Alright, so
V.
they put the thing in the place that is conventional. So go into the T directory and then ls, and you should see backup vstm. Yeah.
Like this?
No column, no nothing, just cd space T. It's a folder. And then ls in there.
Okay, I'm in.
And we should see backup vstm, among other things.
We see all of my folders, yeah.
So now you should be able to cd into backup vstm, then Faust libraries master, then dx7. But remember that you want to use forward slashes and you want to be strict about capitalization. Or not. It works.
It works. Case insensitive. How I love you. Oh, we're in. Now, I guess I just type make libs because in the instructions it says just run make libs.
Okay, so you are in the right folder.
Yes, I am.
You're gonna run make libs. Can you pull the terminal up so that it's not in front of our faces?
Like this?
Even further up if you can. Or make the window smaller or something. All right, run it. Let's see what happens.
Oh, command not found. Oh, wait. You have to type.
You know it, yeah. No space.
Whoops. Oh, yeah, exactly. No space. Boom. Oh, it's looking for this tool.
So now you have to install Faust in the Windows Subsystem for Linux. Because you see, the way that, at least to the best of my understanding, the way that Windows Subsystem for Linux works is that you have a Windows machine, and then it's essentially like a virtual machine for people who have worked in
like a virtual box,
and stuff like that, or VMware, or others of the like. So stuff that you have on your Windows machine may not be installed on the VM and vice versa.
Exactly. So now I have to install Faust. We can do it. Let's go to GitHub. We can never have too many installations of Faust, can we? By the way, speaking of Faust, I really tried to implement my beloved emulation of the Oberheim filter from Faust to that HISC template. I have done it before, but not in this one, because apparently that template was using 4 outputs. Anyway, there is a link on how to compile. Sorry. Oopsie. There. And I think there was a documentation called compiling and installing. Oh, wait. Silly me. It's right here. It's in the wiki of the GitHub. So does it mean we have to also install Git in the Windows Subsystem from Linux?
But if all we are going to do is just Git clone, then we can get by without installing Git. But installing Git is not that hard too, so we may just do that because it may be good for you to know how to do that, which is not even that hard, hopefully.
Okay.
No, I can tell you what to do. So go to the command line for Linux, and first of all, let's check if it's not already installed. Just run git. It is already installed.
Oh, looks like it is. So let's just copy this. Oh, but is it going to install it in this
it's
path?
It's going to download into this path, correct. If you wish, we can go somewhere else.
Yeah, I want it to be installed in the home of the subsystem.
When you say the home of the subsystem, do you mean the directory where we started? So just run cd, no arguments. And can you please pull the window back up to where it was? Because now we cannot see the prompt anymore. Great. So now you're back home.
Now let's type. It doesn't allow me to copy paste, so I have to type the whole thing, but whatever. Git clone https github.com/gram cncm faust.git. Oh, yay, it works. I have used this command so many times in Windows.
Oh, really?
The only annoying thing is that it also creates a .git folder which has duplicate files of the entire repository, which you have to delete manually.
Well, true. There are command line flags you can pass to Git to have fewer files in there, but I don't think there is any command line flag that you can use to not even have a .git directory. But anyway, when you're running Git on the command line on Windows, do you use the Git shell?
No, it's just exactly the same thing. Like I open command line, I go cd with the cd to the folder I want to clone a repo, and then I copy paste the exact same thing and press enter and let the magic happen.
Yeah, maybe it is the way to do it, but there is another that maybe that's the best way to do it, is what I mean to say. But there is another thing that it used to install. I'm not sure it still does, but back in the day when you installed Git on Windows, it came with the Git shell, which is bash. So you would be able to run some bash related things there.
Oh.
And also I should point out that the whole
it's almost done.
bash script that we are running looked very simple. It looked like just a for loop or something. So we could perhaps not run that script, but do what it does without Windows Subsystem for Linux and without installing Faust again from scratch and all that. But anyway, it seems like we are at 50% of this download. So can we leave this running, and then I can share briefly what I have been up to, and then we come back to it?
Sure.
So I will share with you. It's gonna. No, you don't have to. You can keep your screen share. It doesn't matter.
Okay.
But I will quickly share what I worked on in December. And it was on the EWI. So to recap, An EWI is an electronic wind instrument. It is essentially a MIDI controller, but it is a wind instrument. And we started working on this project. We were able to do capacitive buttons. So when playing the EWI, you won't have to like press on a push button. You will just simply touch a pad, and that will be registered as you playing that note. And we were able to connect the capacitive button to the part that sends MIDI events. So all of that is still in prototype form in this Raspberry Pi Pico. But the capacitive buttons are these wires hanging. And in the physical construction of the final thing, this will be part of the body of the thing. And then you will touch this. It will not simply be a wire. And then, so that was the stage as of the last meeting. What I did in December, or what we did in December, was that we looked into this other module here. This guy. So while this is the Raspberry Pi Pico, it's the brains of the operation. This is what has all the buttons connected to it. This is what connects to the computer. This is sending the MIDI messages and all that. This is another module that is a little microphone. This black dot is a microphone. And it's a ready-made module that costs like €5, which is very little, but still more than the Raspberry Pi Pico, which is crazy if you think about it, because this is like a full microcontroller. But anyway, so what this does is, it has 4 pins connected to it, here below. And 2 of these pins are for power, and those are the red and black wires. We are collecting the 3.3 volts from the Raspberry Pi Pico and the ground from the Raspberry Pi Pico and sending that to the microphone module. And this little board will have not only the microphone, but also the preamplifier that you need to drive this microphone. So you can actually get signal from this without any other circuitry. This is a self-contained microphone module. The output of the microphone is communicated with one of these pins, the third pin here, the blue. And then what we did was we hooked this up to the oscilloscope, which is not on my desk, so I'm not going to show you that. I'm just going to tell you. But we hooked this pin to the oscilloscope and this ground to the oscilloscope. And you can see that we are just getting energy from the Raspberry Pi. So when we did that, the Raspberry Pi was just a power supply. But in the oscilloscope, we could see a waveform, and as we like on the microphone, we could see levels on the oscilloscope. And that was very rewarding. And while we were looking at the oscilloscope, we even adjusted a tiny screw on this blue box, which is a variable resistor, I think, or maybe a variable capacitor, not sure. But I know that it's variable, I know that there is a screw there, and this adjusts the sensitivity. So as we were turning this screw, and we could see that it was getting less sensitive, so we would blow the same amount and it would move the curve less, or it would move the curve more. And then we found a sweet spot where it was able to detect even like a, but also able to detect like a. So we left at that. And the next step will be to plug this blue wire back into the, or not back, but plug the blue wire into the Raspberry Pi Pico, because an oscilloscope is measuring voltage and plotting that voltage over time. As it turns out, that is an ADC, an analog to digital converter, because my oscilloscope is digital. Inside the Raspberry Pi, there is also one analog to digital converter. So we can do the same thing that the oscilloscope does. We can measure the output from the microphone, and we get that as numbers. And then we are going to use those numbers to do something. Like the first step is just going to be like plot the numbers on the screen, show that we can really get the numbers from the microphone. And next, we are going to use those numbers in our Python code to trigger node events, because right now, what we have is the Python code is if you touch the button, then it sends the note. So it's not really a wind instrument. It's more like a piano where you press a key and you release a key. But with the microphone, we are going to change the code so that if you're pressing, nothing happens. But if you press and then it's going to send a note. And it's going to sustain for as long as the note is on. And that's the next step. And then we are going to look into velocity and aftertouch and sustain and all that. But the minimum viable EUI is just something that will send notes as we blow. And then we also have to figure out the fingerings that we want for this. And I suppose that the EUI has its own fingerings and we can try and imitate that, or we can come up with something of our own that is more ergonomic to the people who are going to play this. We'll see. So that's the current state of affairs in December, and that's the next step.
Sweet. This reminds me of a game. Do you remember that the Nintendo DS actually had a little microphone on it? And yeah, very few games supported it, like Nintendogs. You could use it to talk to your pet. And it was a very janky, very bad voice recognition. But one specific game, WarioWare Touched, which is a hilarious collection of mini games, used it to an extent where you could just blow inside the microphone to make things happen in the games. So it didn't care about voice recognition. You could use it as an EWI. You would blow and then something happened. It was so hilarious because the game is very cartoonish and very humorous. And the fact that it asks you to blow into the microphone and then you see a UFO pop up in the screen or something else. It's when my brother and I first discovered that we were. So I guess that thing basically didn't care about voice recognition. It just wanted noise. It just wanted the input,
yeah,
right?
And I suppose that the microphone in that in the Nintendo DS probably was as rudimentary as this microphone. I know that it is good enough for the purpose of detecting if you're blowing into it, or detect a clap, or detect a knock on the door. You could mount this against the door and you could detect knocks on the door, stuff like that. Now, it would be interesting, and it may be something that we end up doing for the scientific curiosity, to record the signal coming out of this guy and see if the microphone is good enough to like detect voice.
Yeah, or detect levels of blowing.
Well, that we have already seen on the oscilloscope, so that we know is good. But I wonder if it's good enough for like music-related applications. And I suppose it will be a quality comparable to what you have on a phone. A microphone that is good enough. Maybe even the microphone on my laptop that I'm using right now. Microphone that is good enough. But it would be interesting to see. And
you know what would have been funny? If you could make like, that's for the future, but like a library for that EWI that conforms to somebody's voice. So if somebody's voice is a tenor, it becomes a tenor sax. If a baritone person sings it, it becomes a baritone.
Right, yeah, I've never thought about this, but it is true that an EWI and all wind instruments, they detect, of course, when you blow, but some wind instruments also, they sound different as you voice. So, versus, you know, so I don't know if the EWI does this, because I'm recreating something because I don't want to pay for it. So I don't know how it works all that well. I have never played one. But maybe it detects that. And maybe we could as well. We could, on the Raspberry Pi, detect what sound you're making, not just the intensity, but also if you're doing a ah or a ooh. And we could change something. Like maybe if you went ah, it's going to open and close a filter on a synthesizer, for instance. Which would be kind of cool.
Yeah. Yeah, if you can see a live performance, I'm gonna send you a link later from a a saxophonist called Colin Stetson. Do you know him? He's he has created soundtracks. He's known for making sound design with brass. He can make ambient music and stuff with saxophones and stuff. He's very creative and experimental. There is a live performance where he has another microphone taped on his Adam's apple. So when he blows, he also emits a note, and it's like he's creating a harmony with the brass with his own voice. I can't describe it. You have to see it for yourself. It's maddening how he did it.
Crazy. I know that Bob McFerrin does that with. He can like sing two notes at once, like one with like his chest and the other with the top of his mouth. It's crazy.
Oh yeah, overtones. Also, the late Chester Bennington of Linkin Park could do it. Anyway, so the Git is done.
You're back.
Now we have to go back to that folder, and then I forgot. Is it CD? No. How do we go back here? I have to first type MNT.
/MN. Oh no, actually, say just CD and then space and then dash. No, not slash. Dash. Oh, it's over.
Oh, dash.
With dash, you go to the previous place where you've been. But now it's over because you already went to another direction.
Oops.
So CD and then /MNT, and you need a space. No, it's between CD and slash.
Okay.
Before the slash. There.
Let's see. Then I type CD T. Oh. Why did I forget what I wrote 5 minutes ago?
No, it's just
codes.
No column. It's just CD space T.
Okay. Now we're in. So now I can get all this stuff from here. Boom. And there we go. Now what was it called? Make libs. /make libs.
We have cloned the repository, but have we followed the rest of the instructions? I bet that there are more instructions.
So let's go to the README again. It says tool/dx.
You had a page that was that had instructions on how to install.
You have to run CD Faust. Yeah,
you have to CD and then you have to make and then sudo make install.
Okay. So do I go back to the home?
CD and then space and then tilde. No, just CD and no arguments. And now you're home. And then CD Faust. And then make. Which in all likelihood is going to fail. Yeah. So I don't think we want to install make or make guile. I think we want to install build essentials. Let's sudo apt update. And that is going to update the lists of packages that we have. This, by the way, is how you would install Git if it wasn't installed. You would have to run sudo apt update and then sudo.
Do you use Linux for work, if I may ask?
Huh?
Do you use Linux on your home environment? Because I haven't seen you use Linux at all.
Well, I use Linux on my servers. I use Linux on one development machine that I have in the closet that I use to test stuff, like when I do Reaper scripts that may use something that is system dependent. I tested on that because Reaper runs on Linux. And back in the day when I was before I went to grad school, and for some time in grad school, I used Linux as my main machine. I used it as my daily driver. But anyway, so now that we did that, we want to run sudo apt install build -essential. Yeah.
Like this, or essentials?
I think it's essential, but it may be essentials. Try and run, and we'll see if it works.
Oh, it works.
Yeah. And as you can see, you can type yes for that question. As you can see, there is a huge list of packages. So there is going to be not only make, but also a C and C++ compiler, and all the apparatus that you know in Visual Studio. When you install Visual Studio on Windows, it comes not only with the text editor, but also with everything you need to build software. That is the Ubuntu equivalent of that. It doesn't come with the text editor, but it does come with everything in the toolchain. So the C++ compiler and everything else. And we'll see if that's enough.
Theoretically, this could help me build Linux plugins from HISE.
Perhaps, because...
If not, I'm just going to use VirtualBox, but yeah, it's worth a shot.
Oh, do they have a VirtualBox image that already has all the tools?
No, but David Healy has a tutorial on that.
Probably if you can follow the tutorial on a VirtualBox, you could follow it on the Windows Subsystem for Linux. Oh, and now what's scrolling across the screen is it is installing a bunch of things that start with lib something. And now it's saying GCC. The libs are, you know how in C++ we may say like hash include string, for instance. It's in those libraries. That's where it's coming from. And GCC and G++ are the compiler, or the compiler toolbox, because it also includes a bunch of other things. And now it's installing some fonts, and I don't know why it's so much. And now it's installing some graphics.
There's
stuff,
also
like,
there's also libgl. We're probably gonna see libgl as well from OpenGL.
Yeah, we can see lots of stuff for graphics from JPEGs, WebPs. Oh, and another one that is on the screen now is very interesting. libc DevTools. libc is the standard library of C and C++. And now it's processing the triggers for man-db. So if you are ever on the command line and you say like man something for manual, it will look up on this database that is being updated now, the man-db.
Sweet. It's almost done.
And what I understand is about these triggers is that they are not only placing files in your file system, but they also need to run some code. All right, so now try to run make. And in all likelihood, this is going to work, but it's going to take a while. Because as you can see, it's saying cloning into blah, blah, blah. So it's now downloading stuff that it needs besides the compiler. It also needs some dependencies, right? A project doesn't exist in an island. So it's now downloading stuff for Android that it needs. And it will download stuff for physical
maybe
modeling.
that's where the tool is. Maybe if we see a subfolder called tools, in here. Maybe that's where that thing is, the DX7 to Faust thing. Because if you see in the README, you see tools/DX7 to Faust. And I couldn't find that in the repository I downloaded. So it's probably
the result of building
in those places. Oh, there we go. Tools. Yeah. There is already one. Okay. I'm excited.
And this may take a while because
it's going to take a while. Yeah. Let's wait.
And not only that, it's going to compile a bunch of things. And compiling can be slow. And
yeah, so let's...
Yeah.
We can put a pause on that.
Leave it running and come back to it.
And
we'll see.
Yeah. Anyway, while it's working, I wanted one final thing to show you before we wrap up. Again, we're gonna go to Cardinal. So between watching endless tutorials on YouTube and whatnot, I have also checked out some books and stuff about synths, and basically I have become to slowly get the gist of it. But I want, like, if you want to show you a very fun thing that you can do with Cardinal and Reaper. I don't think I have shown this before. So one cool thing that Cardinal has is called host params map, and it allows you to connect any knob or fader on your module to these plugin parameters. It gives you like 24 ones. So let's say that we want to modulate this oscillator. My volume is... Oh yeah, we muted it because we had that Faust thingy. And now it's too low. Anyway, so let's say that we want to modulate this LFO, but not with this VCO, but not with an LFO, but with Reaper's parameters. So what we do is click here to map, and then we move this thing. Now it has been mapped. Now we go to this parameter and go to parameter modulation and go LFO, let's say random. And it's moving. So yeah, you can basically map any parameter you want, and also you could use Cardinal to modulate other VSTs even. Like you could use this link to parameter via. You could go to another VST and click this one and load Cardinal synth, and then you could actually use a parameter as a macro controller for another VST. And one more thing that I wanted to show, again, this is by Distro, the person who makes Cardinal. Where is it? I think it's, oh, there it is. It's called Ildail. Have I told you about this thing?
Don't think so.
Do you know what this does? It says LV2.
Yeah, it's probably going to load
if I click
VSTs and other plugins inside a plugin.
Yep, but not just that. It can load drumroll.
JSFX.
It can load JSFX, yes. Yes. So you can go here. I think the drop-down menu is somewhere right here. But yeah, you can actually load JSFX in any DAW. It's not perfect, but it works. And you can actually use JSFX as part of a modular synth. How cool is that? Because what I plan to do, the reason why I created this and why I want to build this one is because this thing is converting C6 system exclusive files from the Yamaha DX7 into Faust readable files. This is the default, but this is not. This is from a pack that you can get for free on the internet. It's for the VST Dext, which is an open source emulation of the DX7. This is just a piano patch. And I was thinking if I could port this into Faust readable format, I could actually create a clone of DX7 in JSFX. So Tail would be super proud of me because he developed the DX7 for Arturia, didn't he? And there are tons of emulations for DX7, the Arturia one, the Dext, the Native Instruments FM8, the Chip Synth OPS by Plug. But are they in JSFX? No, they're not. So we're gonna do what nobody else has achieved before. Oh, wait, it ended.
Oh, there is an error message somewhere.
Yeah, I don't like it.
It is complaining about C not found.
Oh.
What would be the thing that is not found?
Well, maybe CMake. It doesn't have CMake because it needs CMake here.
Ah, that may be the problem, yeah.
So we have to install CMake as well. How do we do that?
That may be the case, but let's see. Can you run CMake and see if it's installed? But it's teaching you how to install it. How convenient.
Okay. Thanks, Linux.
And again, it's installing
yes,
not only CMake, but all the libs and like auxiliary stuff.
Well, good thing I freed up a bunch of space on my hard drive. So yeah, Linux can install everything at once. Okay, so I guess I can try this again later, like the same command as before, and see if it works. So can we wrap? Fingers crossed. And next time maybe we could also play Signal State. I actually invited Rolf Kasten to see. Rolf Kasten is a Czech YouTuber from the Czech Republic who is like a wizard of modular synths. And I have been talking to him recently. I told him that maybe we could make a live stream with him so that he can actually explain some of those hardcore modular concepts to us mere peasants.
I would like that, yes. Let's make it happen.
Yeah.
And also, if you are out there, Toucan, we want you here because Toucan has made something really cool, an Advent synth. So every day there was a new feature on the synthesizer, and we want to see how it was done.
Yeah, I watched those videos. They were amazing.
Yeah, he is great. And I'm looking forward to having him here with us. All right, so that's it for me. I think it's a wrap, right? All right, so I want to thank Bo for joining us here on the chat and everyone else who's watching this either now or in the future. And thank you, Fotis, for joining me. Looking forward to what we come up with.
And I apologize. For any hearing loss caused by the beginning of the stream.
And I apologize for being half an hour late. You know, it's one of those things.
That's okay.
I don't get important calls often, but if I am going to get them, it's going to be 10 minutes before the stream. So it goes. But anyway,
Murphy's Law.
I am happy to be kicking things off for 2024. I'm looking forward to what we all end up creating. And I will see you on the next one. Bye.
We haven't picked a date yet.
It's going to be soon.
But we will.
It's going to be soon.
Soon, yes. When it's done. Bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.